Hi everyone. Now we will introduce the sampling and sampling distribution part 3. And today we would like to introduce the sampling distribution of the p-bar. So here you would like to know the sample proportion p-bar in such notation. It is the point estimator of the population proportion P. So when you would like to know how to compute the sample proportion, you need to know there is how many sample size here. Then you can calculate how many people they participate in the training program or the element you are interested in. So you can calculate the result of the sampling distribution of the proportion in your sample. So in those ways, we can use the sample distribution to make an inferences about the population proportion. So first, you need to use a population and try to use a simple random sampling and to choose the element such as there is n elements you are interested in, so you select them from the population. Then from such sample data, it will provide a value for the sample proportion p-bar. For example, in the EAI example, there are 2,500 managers as a population, but you will select 30 as a sample. To calculate the proportion of the population, about how many of them have finished the training program. So the value of the p-bar will be used to make an inferences about the value of p. So you can calculate the population with the proportion of p. So here, to determine how close the sample proportion p-bar is to the population proportion p, you can use the calculation to learn it, but you still would like to understand the property of the sampling distribution p-bar, then you can calculate its expected value, its standard deviation, or the sampling distribution of it. So here you can use the expected value of the p-bar. It would be equal to the population proportion p. And because of the expectation of the p-bar equals to the population of the proportion, so we can say the result from the sampling proportion equals to the population proportion. So the sampling can truly reflect the reality of the population. So they are the unbiased estimator of P. So when you would like to know the standard deviation of the p-bar, you need to do in your first step is to know whether the population is an infinite one or finite one. So when you decide or learn to know the population is a finite one or infinite one, then you can use the following formula to calculate the standard deviation of the p-bar. In the finite population and infinite population, you will find they will have the common portion, that is, they will have the sample size, and then there will be the proportion about the sample, and 1 minus the proportion and multiple then get the root of them. But the difference between the finite and infinite population formula is in such bar. In such part, we will call it is the finite population correction factors. When the size is a finite population, but its size is very large, especially compared with the sample size. Then you have to think about in their division. Well, when they are divided, will the value be less or equal to 0.05? And if yes, then you have to use the infinite formula, even they are an infinite one, because in such a result, that means the population is very large, but the sample size you select out is relatively very small, so it can be viewed as an infinite one. But if the population is finite one and the size divided by the population size that is more than 0.05, then you should use the finite population formula to calculate the standard deviation of it. So unless the specific noted, usually we will assume the population is large in relation to the sample size and the finite population correct factor is unnecessary. That means we usually will view the results as an infinite one unless the question tells us that it is an finite one. And then in the sampling distribution of the proportion, we can also approximately to say whether it is a normal distribution. So here you can focus on whether the sample size that is large enough to satisfy the following two conditions. That is, the sample size multiplied by the proportion of the population or the proportion of the sample that is large or equal to 5, and the number of the sample size that multiplied by 1 minus the sample proportion if they are more than or equal to 5. If yes, they can satisfy those two conditions, then we can say in such condition they are can be viewed as the normal distribution one. So later we will use an example to show whether is this EAI sampling they are the normal distribution one or not. Especially when you focus on such questions, you will find its proportion of the sample is 0.60 and its sample size is 30. So when you follow such two conditions, you will find when the m multiplied by the p, you will get 18, and m multiplied by 1 minus p, you will get 12. And all those two, both those two conditions, they are more than or equal to 5. So we can say in just such condition, they can approximately be viewed as a normal distribution one.